All right, let's go ahead and get started on time today, which is nice. Hi, everybody. Hi. All right, let's just go back and quickly review what we've learned so far. By the way, the reason I have you do hi, Clay, is because it's weird for a lot of students to call a professor by their first name, so we're just practicing. Like we're practicing other things in the class, so we get better at it. So the last times we talked about algorithms. What is an algorithm? An ordered series of steps used to complete some task. Why does this matter? Because a program is... Yes, rah, 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 rah is absolutely right. That's exactly what I said. A program is just an algorithm that we can read, the human runs. I keep reinforcing this because it's important. If it seems like I'm doing it too many times, I don't care. All right. So last time we started talking about some stuff, and we gave ourselves a simple problem. And the problem was to do division in such a way that the user could choose whether they wanted to divide by integers or divide by floating point, and then divide two numbers. Pretty simple algorithm. And we started doing this by doing some algorithm development. And the way I did algorithm development was how I do it for my own projects, which is to just outline what I think the project's going to need to do using comments, right? So one of the things that we talked about last time was comments. Anybody remember what a comment is? Yes, sir. Exactly. Something that the computer ignores, the compiler ignores. It's not part of the computation of your program, but when other people read your program, it assists them in understanding what you're doing. Okay? So we talked about those. We talked about variables and constants. What is the difference between a variable and a constant? Yes, sir. Exactly. Variables you can assign different values to over time. A constant, once you have assigned it a value, stays that value forever. Okay. We talked a little bit about output. What does C++ use for output? Cout, and we'll talk more about that. We talked a little bit about input, and what does C++ use for input? Cn, and they have the angle operators that I like to think of as funnels that stuff data places. We talked briefly about using debug statements. Remember what the example of a debug statement is? Yeah, Kitty. Yeah, it's a print statement that is not part of our algorithm, but which we can put in pretty much anywhere we want, just so that we have some idea of what's going on inside our program. Okay? So we put this debug statement in while we're developing our program, and when we're done, we just take any of those print statements out that aren't relevant to our output. Okay? So you can add things to your program. You can have your program output additional stuff as you go along to make sure you can see what's going on inside. And you just take it out when you're done. Okay, this is the cout statement. Okay, today you should have turned in homework number 2. How many of y'all got homework number 2 in? Pretty much everybody. Homework number 2 was about, to go back to my analogies on the first day, raising llamas, braiding hair, and tying knots. Right? I'll never mention that again. But really it's about using the tools for this class that we need to do. The basic editor, which was Nano, and the compiler, which is G++, and using them so that you could enter code and compile successfully. Everybody was successful at that? Okay, good. It's pretty straightforward as long as you don't have errors. How many people ran into errors in their program while they were working that they had to fix? Good, a lot of you. In the past, maybe I should do this in the future, the program I've put up on the web page has had purposeful errors, and I've told you to fix those too. I don't know, I was feeling in a good mood this semester, so I didn't include that. Let's just hope I'm not grumpy around exam time. That's all I have to say. So you have some basic familiarity with the tools you're going to need to build your code, the editor and the compiler. Project 1 is posted on my webpage, and I will add it to Blackboard this afternoon. Project 1 is large. It's a bigger project in terms of the amount of code you have to write. However, there is a significant amount of repetition. So it's not large in terms of the number of different concepts you have to master. So let's just take a quick look at that, and we will see what's going on with project 1. All right, so this is project 1, and what we're going to do is we are going to build a risk score calculator. So every semester, when I teach this class, I come up with new projects. And each semester we have a theme. And sometimes I let you vote on the theme, but I always get things like One Direction and Jersey Shore and stuff like that that I don't even understand, so I tend not to follow those. This semester we're doing an epidemiological study. Okay, everybody know about epidemiology? Anybody? So epidemiology is the study of disease and healthcare treatments in large populations. And what epidemiologists do is they enroll people in a study, they get doctors, and then they give them particular treatments. And the treatment might be drugs, it might just be an interventional treatment like, talking to them about their health, things like that. And then they study their health over a period of time to see how that treatment worked. Okay. So in this treatment, what we have is we have a cohort of female subjects ranging in age from 20 to 79, and we're doing an interventional study on heart disease. So what the researchers need is that when they take patients and enroll them in the study, they have a counseling session with them and they sit down and talk to them for a while. And as part of talking to them, they calculate what is known as the Framingham Risk Calculator, which is a calculator of the likelihood of developing heart disease over the next decade. Okay? And as part of this, they take in some information and then do the calculator. Now, here's a few notes that I'm going to blow up. I don't know if you can really see. All of the subjects in this exam are female, so you do not have to compute a score for men, even though there's one there. None of the subjects are currently being treated for their blood pressure. So all people are not being treated for blood pressure. The subjects range from age 20 to 79, and there's some possible ranges for things like their total cholesterol, the HDL cholesterol, and their systolic blood pressure. Okay? So, given this information, how do you compute the risk score? Is that what you're wondering? No? You're wondering if it's too late to change classes? Well, it turns out the risk score is actually well known, and you can look it up right here on Wikipedia. And in fact, I did not put any algorithm on my page. All I put was this link to the Wikipedia page. It does not count as a good submission if you go in and change Wikipedia so the answer is always the same, and then you just print out that answer, okay? Anybody thinking about that? Okay, so here's essentially how it works. Subjects are broken down into age groups, age ranges, and the age ranges are here, you can see 20 to 34, 35 to 39, and so on. They're broken down into groups by age and their total cholesterol. They're broken down by age and whether they smoke. They're broken down by their blood pressure and their HDL cholesterol. It's relatively straightforward to compute this. All you have to do is figure out how old they are and the different types of input, their total cholesterol if they smoke, their HDL cholesterol, and their blood pressure. Then you just compare what age they are to the particular ranges and add up all the points. When you're done adding up all the points, there's a little table that does, if you're in this range, this is your risk. Does that make sense? Now let me tell you one thing about how I developed my algorithm to do this. I noticed that all of the age ranges were always the same, right? The age ranges were always the same. So instead of developing an algorithm that every time it needed to look up something based on age range, I just had it figure out what the age range was first, and I assigned it into an age range category. And then every other lookup I did by category. Okay? Same thing by blood pressure, same thing by total cholesterol. I looked at the ranges, and at the beginning, after we entered the information, I figured out which range they were in. Okay? So once I figured out all the ranges they were in, then when it came time to compute, it was relatively just simple to go through and look up and just said, hey, if you're in this range, you get this many points or not. Okay? So that's my algorithm hint to you. Compute total ranges first, and then do the point scoring after. Now remember last time we talked about constants. What are the things that we use constants for? Yes? Numbers that are always going to stay the same in your program. There are a lot of things in here that can and should be constant, right? So if the age range is, say, 20 to 34, these are constants, right? The lower end of the age range, the upper end of the age range is a constant. The number of points you get for particular activities is a constant. Yeah, there's a lot of constants in this.
So every number on that.
Almost every single number on that page is going to be a constant, yeah. Now, you might be asking yourself, well, that sucks. Why do we have to do that? Why don't we just stick numbers in there? And remember last time I tried to use an example is if you just see a number somewhere, you don't know which one it is, right? If we look through here, we can see that you get a lot of 1 points and 2 points for different things. If you just have 1 or 2 points in there as a literal value as just 2, and then it turns out over the course of the study that the people who came up with this realized that, they did further studies and they want to change the score. Going through and figuring out which 1 or 2 is right is difficult. Whereas if we just name them things like, age range 8 under 160 is 0, age range 8, cholesterol range 2 is 1, things like that. We have all those listed at the top, and we can change them easily if we need to. So, you think it's crazy, but if you ever read really good code, it has everything declared as constants at the top. I was fortunate enough to read all the source code for the Nintendo Wii operating system, which was kind of fun, and it had everything declared as constants, pages and pages as constants at the top. And it helped the code readability because as you were reading the code, instead of just encountering some number, you had a name, like a conceptual name for that number. So, lots of constants in this. Okay, you have a week. The first thing you're going to do is develop an algorithm to do this. Right? I've given you some hints about the algorithm. You have 1 week to do the algorithm, and a week after that to finish and submit the code. So this is kind of your overview right now. You can look at this over the next couple of days and bring questions to class on Tuesday. We have questions now. Yes, sir.
When we're declaring the constants in our algorithm, do we have to declare them all in the algorithm?
Okay. No, and thank you for mentioning that. The instructions, if you read them about how the algorithm design is, says you do not have to specifically as part of your algorithm declare all the constants, because that would be annoying. However, in your algorithm design, you should use something that is the name that you would use for a constant. Okay, so as long as you use meaningful names in your algorithm, you don't have to list all 80 constants. When we do our algorithms for this class, we do not have to essentially include the variable declarations. Okay, we'll save that for the C++ code. Okay. And thank you for asking that. I meant to mention that. Other questions? Yes, sir. Mm-hmm. Okay. Okay, so this is age range 20 to 30, 35 to 39. But down here it says, look, age 20 to 39. That's a little confusing, isn't it? But if you think about it, this age range right here is actually the first one and the second one combined. So you can cheat a little that way. Okay? So you can know down here and you say if they're in age range 1 or 2, they get 9 points. Okay. I know it's hard to read that up on the board if you haven't looked at it, but like I said, if you read it over the weekend and have questions on Tuesday. Other questions? How's everyone today? Happy? Sad? Overwhelmed? Just quiet? Quiet? We go with quiet. Okay. Let's go back to this. All right. So project 1 is posted. I just wanted to bring that up. No other questions. We're going to go ahead and we're going to go back to what we were working on last time, which was this code, which I will make bigger. Okay. All right. So this is the algorithm that we were working on. This was the algorithm in which we asked somebody whether they wanted to do integer division or floating point division, took some input and did the division. And here's how far we had gotten, right? We had declared some variables with literal values to initialize them. And I realize I forgot to call these out by name. But when you initialize a value, a variable, and you give it an explicit value, that value is referred to as a literal. It's just a fancy name for an explicit value. So we gave choice an initial value that consisted of a space and dividend and divisor 0. We output asked whether they want integer or floating point division, and we inpointed something into choice. At this point, the user has typed a single letter in, and the value of that letter is stored in the choice variable. And I had a couple of questions, which is, does the computer know what those choices mean? And the answer is no. The computer never really knows anything. All the computer knows is that it has a value stored in a box somewhere, and we are always going to have to write the algorithm that makes the decisions. Okay? Remember, the computer is dumb, but it's dumb very, 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 very fast. So we have to be very explicit. So just because there's a letter in there, computer has no idea what that means. We also inputted two things together, the dividend and divisor. And then we had some debugging statements for what you chose and what we got out, and I commented out one but not the other. So, all right, everybody with me on where we were? So let's look down at the rest of our algorithm. So we've input stuff, and now we have to decide whether we want to do integer division or not. How do we decide things in C++? We have an if statement. So let's write an if statement. And what we're going to say is if. And if what? All right, if choice. Why a double equal sign? Yes, so a single equal sign is making something equal, right? That forces it to be equal. A double equal sign checks to see if it is equal. Okay? The first equal sign is called a single equal sign as assignment. The second equal sign is a Boolean check. I'm going to tell you this creates problems because a typical bug would be, and let me just put something in here, right? Say we say if choice is equal to I, do something. Okay. Right? Everybody with me on that? Let's say that we had a typo and we said if choice single equal I, what will happen? How many of you think good things will happen? How many of you think bad things will happen? You're very perceptive. Bad things will happen. And let me tell you what bad thing will happen. It will look at the computer as dumb and it will go, oh, choice equals I. I need to take this value I and go stick it in the box that I have labeled choice off in memory. That will happen. So whatever choice was before, it is now I, no matter what, okay? Then the if statement evaluates things on whether evaluates based on whether things are true or false. And I told you last class what true and false were. What is false? 0. And what is true? Anything that is not 0. Anything that is not 0 is actually true. So what will happen is it'll look at this and it goes, okay, if choice equals I now put I in that box, and now I decide, is I equal to 0? Is I equal to 0? You don't know, but I'll just tell you it's not. Okay? So it'll go, oh, if choice equals I is true, well, that must be true. And you've just changed the answer of what you wanted, and then gone blindly on believing that the computer goes blindly on, you know, mechanically chugging along like it does, but in my heart, believing that it's done the right thing. Because I do like to anthropomorphize computers. So this is a common bug, a very common bug. Okay. I make this bug all the time. Almost as often as I make greater than or less than errors, which I do pretty much 100% of the time. As you'll see later on when we start talking about greater than less than. Okay, so here's one way that we can protect ourselves against this type of bug. And what we do is we do this. We flip the assignment around and we say if I equals choice. Now here I still have used the wrong equal signs, right? I've used 1 instead of 2. But what the computer will do is it will say, oh, you want me to find out what's in choice and assign it into I. So it'll go, okay, it'll look up choice, and it'll have some value in there. And it'll go, now assign this into I, and it goes, whoa, 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 whoa. Wait a minute. There is no box named quote I quote. That, in fact, is not even a legal variable name because it doesn't start with a letter or digit, and it throws out an error. The compiler will detect this and throw out an error. Okay. So this, because you cannot actually assign a value to a literal, the compiler will catch that. And then you go, oh, I should have had double equal signs there. Now I'm happy. Okay. Sir?
Shouldn't it be also capital I?
Okay, we'll get to that. We'll get to that later. So we have if I equal choice. And this is a safer way to do this test. Like I said, I'm sometimes going to be trying to teach you. So I'm going to go ahead and fill on this out. So if statements have these curly brackets around them to indicate what to do. And they also have, if we want, an else statement that also has its curly brackets around it. So I'm just going to go ahead and put all these things inside the curly brackets. Okay. So now we have our algorithm for each side. Okay. Everybody with me? Yes? No? Yes? Maybe? No? Okay. All right. But just remember we have a decision. The decision takes something that's true or false. False is 0, and anything that's not 0 is true. Double equals lets us check things and returns true or false. Single equals set things, and it's easy to make a mistake there. Yes, sir? Yes, and we haven't gotten to that, and we will. But just know right now, if you have a character, a single letter, it gets single quotation marks. Okay. And we'll talk about double ones later. Yes?
So as the code is now, are we assuming that the choice is not I and it's D because we don't have any signs?
That seems to be what we're doing right now. Right now, we ask the user to enter either an I or a D for integer or thing. So we said I, if you have I, you're going to do integer, and if not, you must have typed D because that's what we asked you up here. Right? We said I or D up here. And then what we're going to find later on is that humans range from imperfect to suck, and they are not going to be able to follow our very clear and simple instructions and type the right thing, and we're going to have to deal with that. But let's do that later, okay? Everybody okay with doing that later? Okay. Okay, so here we are. We've decided we're going to do integer division. So now what we have to do is take our two numbers and divide them as integers, and what we want to get are two results. We want the result of division, and we want the result of the remainder, and we want to output those. Everybody good with that? Okay, so the question is then, how do we divide two numbers? I saw you waving your hand around. With a slash, yeah. So all we have to do is say dividend divided by divisor. Okay. Does that seem right? Okay, so remember, when I talked about how memory works and how the computer, the CPU, talks to memory, it will happily fetch things for you and figure out what divisor is, and figure out what the dividend is, and do that math computation. But unless we explicitly use the equal sign, the assignment, it will immediately forget that it ever did it. Immediately. And it will not store that result anywhere. Because the computer is dumb. And it does what you tell it rather than what you want it to. So you have to be very precise. So if we want to remember what happened here, what do we have to do? We have to assign it someplace. We have to put it into a variable. Otherwise, it will go, okay, divisor, dividend, no problem. I'll do the math. I have the answer. I'll just go on to the next thing. If we don't explicitly tell it to put it somewhere. So we have to tell it to put it somewhere, which we do using an equal sign. And where are we going to put it? We have to make a new variable. Okay. Now, we could make a new variable right where we are, but that would create problems. And I'm not going to tell you what problems it would create. I'm just going to tell you it would. So instead what we want to do is we want to have something up here which we're going to call an integer result, because we might also have a floating point result. So here we're declaring a new box in memory that we're going to call integer result. And then back down where we're doing the division, we will store our result. Okay, we do not need to, but it is good programming practice to always initialize your variables. So I'm happy to do that, because otherwise you don't know what's in there. Okay. Everybody good so far? Let's take a yes question. Okay, so I declared the variable up here, and I said int result equals 0, and down here I said int result equals dividend divided by divisor. No, you can't. It is not the same situation as we have up here. The assignment side, and actually you've stumbled on something that I wasn't going to tell you because it's more than you need to know, but since you brought it up, let's just have it out in the open. In computer science, there are things that are called L values, and there are things that are called R values. An L value is something on the left-hand side. Sorry, I'm backwards. On the left-hand side of the equal sign, which is something that you can actually store things in. It's called an L value. An R value is something that is computed. So you never need to know that again. It's not going to be on the test, but just for completeness. Okay. Notice, yes? Yes, and I should have said that. Every line in C++ ends with a semicolon. It's like the period at the end of the sentence. And if you don't have that, it will complain. It'll get confused. Yes? Yes. You can put them after a bracket if you want. Sure. Doesn't make any difference. Why it goes the other way? So whatever computation we do is always on the right-hand side of the equal sign. And what ends up happening is it does all the computation, and we'll talk about the order. And when it's done, it puts it to whatever on the left side of the equal sign. Now, I confused you in talking about this if statement up here. Where did it go? Right here with the double equals. So does that make sense? Just as a basic rule, everything on the right side is the computation, and everything on the left side is where the result is stored. Okay. Let's take a 1-minute break, stretch, shake it out, do whatever you want. You can stand up. It's good for you if you want. Okay, welcome back. Any other questions occur to you while we were shuffling around? Okay, so here we are. We have gotten what choice they make. We've gotten the dividend advisor. We have done the integer division. What else do we have to do? If we look at our algorithm, we'll see we have to divide two numbers as integers, and then we have to do what? Mod. And what is the mod operation? It is the remainder of integer division. So to do this, what we're going to do is we would do dividend mod divisor. And what have I just done wrong here? Again, I've told it to do the computation, but I have not told it to put it anywhere. Okay? So if we want to put it somewhere, we always have to put it in somewhere on the left side, and we need a variable to put it in. What variable would you like to put it in? Let's call it int remainder. And just because we're putting all our variables up here, we will do int, and we'll initialize it. Uh-oh. Did I spell it wrong? I have to say public speaking is hard to get used to. Public typing is really hard to get used to. Okay. So we have int result. Now we'll do int remainder. Great. Now, at this point, I'm just going to go and I'm going to compile the program really quickly. I like to do this frequently just to make sure that I haven't introduced any errors as I've gone along, right? If you type out the entire program and you do everything and then and only then at that time do you compile, it's much harder to figure out what you did wrong if you do that instead of compiling every so often. Does that make sense? Like, catch your mistakes early and they're easier to fix. So okay. So I did some magic because I've been doing this a long time, but the gist of it is that I went back and I did this divide, G++ divide. It compiled. We don't have any apparent syntax errors right now. Okay. So here we are. Now what's the next step? We've done divide two numbers. We've done mod two numbers. What do we have to do next? Output. How do we output? Cout, angle, angle. What would you like to output? What should we say? Pardon? Okay. Well, we have two numbers. Would it be nice to label them somehow so that the user knew which was which? Right? Quotients. That's the word. I should have. Quotient. So we have the quotient, which is the int result. And then what I'm going to do is I'm just going to put a space between there. I don't have to do that. I'll do this. And remainder. So here's what I'm outputting. I'm going to center this on the screen and make the font a little bit bigger. Sorry, is that easier to see? So here's where we did the int result. Here's where we did the remainder. Cout, angle, angle, double quote. And I'll just give you a quick guide. Somebody asked me about the single versus double quote earlier. I'll give you a quick guide. If you're printing out one single letter or character, it's a single quote. If you're printing out multiple ones together, it's a double quote. And we'll go into more detail about why that is later, but that's just a simple rule for now. Everybody okay with that? Yes, sir. If you have more than one letter in a row, like in a message that you're outputting, it's a double quote. If you have one single letter or character, it is a single quote.
And that's the same if you're outputting one character?
Yes. Now, you can cheat, and if you're only outputting one character, you can also use double quotes, but just as a rule. And we'll see why that is later, okay? Just trust me on that for now. It's part of the necessary magic to make this happen. Yeah?
So are the spaces important on code?
Yes, they are. And I'll show you why. Let's go ahead. How many of y'all think this is going to work? How many of you aren't sure? It's great to be not sure. You haven't done this much yet. How many of you think it's not? Why do you think it's not going to work?
Because of the spaces, I think that they are going to affect.
Okay. Let's try it and see what happens. And let me tell you something here. I've shown you as I'm going along, I stop and compile every so often, right? The nice thing to do is as you're going along, run your program every so often too. If you've written enough that you can like test that little portion, go ahead and run it and try it. The other thing about this is that you have a computer. All of you have a computer, access to a computer. You have a compiler. If you're ever curious about how something works and if it's going to work or not, you can just try it. The computer is the ultimate oracle for you. It will have all the answers for you about whether you want what you're wanting to do works or not. Okay. So go ahead and try it. I can assure you it is very difficult to ruin your computer or do anything bad with the stuff that I'm teaching you in class. Okay? So if you do the stuff I taught you in class and you run the program, you should never like erase your hard drive or set your computer on fire or anything like that. Okay? I can assure you that. Later in the coursework of computer science, I would not say the same thing, but here it's pretty safe. So, all right. So let's go ahead. We'll compile it again, and I'm just going to clear the screen a little bit so we can see. All right. So I ran the compiler. It worked fine. There were no errors. I'll make the font a little bigger. So now I'll run it. All right. Do we want to do integer or floating point division? All right. We'll try I. Great. Input. What do you want to see divided? How about 22 and 7? We'll see if we get close to pi. It says the quotient is 3 and the remainder is 1. Right? 3 times 7 is 21. We enter 22, remainder of 1. We're good. So this seems to be working, at least for this case. Now, we were a little bit concerned about these spaces. I threw some extra spaces in here, right? So let me go through and take these spaces out, and we'll just see what happens. Are these the spaces you were worried about, or the ones between the double angle brackets? Or both? Okay. So I'm just going to take all the spaces out, and I will show you that what's going to happen is that the code is going to run absolutely correctly, but the output is going to be kind of ugly. Okay? It's going to be a little bit ugly. So I took all the spaces out of that line. I'm going to go and run the compiler again, because every time we change the source code, we don't actually change the program unless we rerun the compiler, right? The compiler takes our source code and makes it into a program. And then when I rerun this program, it will say choose integer or floating point. Which do we want? Integer. 2 numbers divided by space. And now you can see we got the same answer, quotient 3, remainder 1, but it was all smushed together in a giant incomprehensible block of text. Does that make sense? So what we're doing in our output, when we look up here, whatever we print, it's literally going to print this thing out. And if we do not have a space between the end of the message and the number, it's not going to have a space on the output, right? So we need a space there. And the other thing is if we go back and look, you can see there was no space between the output and the next message, that it was a remainder. So the computer, again, it's very dumb. It's dumb very fast, but it's very literal. It's going to be very literal in when it outputs. So I'm just going to go ahead and put all these spaces back in. Also notice that the compiler worked even though there were no spaces around the angle brackets, right? The compiler in general does not care about spaces. In fact, I could run a command on this code that would take every single space out of the program. I could run a command on this code that would take every single return out of this program, and we could make this code one giant dense block of text, and the compiler would be perfectly happy with it. It would go through and it goes, I see a semicolon, that's the end of the line. I see some curly brackets, I'm good. But the humans who had to read your code would hate you. Okay. So a lot of what we're doing in formatting our code is not for the computer, it's for other people. And it's kind of neater to have the spaces there. It's neater to have good output and stuff like that. So, okay. Everybody with me on this? So, how's our algorithm going? It's good, we're halfway there, right? We got the integer part working. We're more than halfway because we have all the input working and integer working. We're pretty happy. All right, so I'm just going to go back. I'm going to recompile this. Oops, sorry. I'm going to recompile it. I will rerun the program. Which do we want to do this time, integer or floating point? Let's do some floating point. 22 and 7. Oh, nothing happened. Why did nothing happen? Yeah? Exactly. We haven't written that part of the algorithm yet. So shall we go write that part of the algorithm? Awesome. Okay, so here we are. And down here, this one looks pretty easy, right? We want to just divide those numbers as a floating point operation. So, how do we divide numbers as a floating point operation? Pardon? Okay, well, let's just try what we would naturally try. And the thing we would naturally try is we would say, okay, we want to have a floating point result, so let's do this, float result. And this one will set equal to 0.0. And this time I use the 0.0 to indicate when you read the code, it's pretty obvious it's a floating point because there's a decimal there. So let's go take a look at that. And here's what we'll try is we'll say, okay, float result equals dividend divided by divisor. Did I do something wrong? Oh, okay. Another super common mistake. And I actually just made it naturally there. But here's what happens. Let's try it now. We declared this thing. You saw what I did. I declared this variable up at the top, right? And then down here in this block, I declared it again. What do you think is going to happen when I compile this? All right. It's not. It's going to work. All right. And here's the deal. And we'll get into this deeper in the semester. But if you are inside curly brackets, you can redeclare a variable, and it will override the one that's outside of the curly brackets. Oh, sorry. Float. Oh, well, let me show you then. Now do you believe that they have the same name? Now do you believe that they'll compile the same way? Yep. Okay. So again, this is a common mistake people make when they start programming, is they will declare their variable up at the top, and then they will redeclare it somewhere else. And because of the way the language works, and we'll see why this is later, things inside curly brackets override the other ones. It's not going to make much of a difference in this program, but it can later. Yes, sir? No, you can't. Once the type is set, it's set. Sort of, okay? Sort of. Sort of. The people who are programming are all squinting at me, looking at me like they're skeptical and stuff. So, okay. So make sure when you declare a variable that you do not redeclare it. It's just a general rule of thumb. Later we'll see why you want to do that. Okay. But for right now, just declare all your variables up at the top. Okay. How many people did I confuse by that long diatribe? A little bit. Okay. So here's your rule. Okay. You don't need to know why. Just declare all your variables up at the top of the program. Don't redeclare them anywhere else, or you'll run into problems. Is that an acceptable, simple rule? Just declare them at the top. Yes, sir? Yeah. Yeah. And the other thing about declaring it at the top, I mean, it's actually, depending on where you are and what the coding style for that environment, most people just declare everything at the top anyway. And the reason is because, you know, we're working on relatively short programs here that are relatively short files, but some program files have like 5,000 or 6,000 lines of code. And if you're reading down near line like 4,870 and you come across a variable and you're like, I wonder what that is. It's easier to go up to the top and find it than to search through the 4,869 lines of code before it to figure out where it was declared. Yes?
If you're doing this sort of an isolated operation within one scope, do people generally declare the variable in there?
If you did not understand this question, it's fine, and the answer is yes. And we will get to that later. Okay. But we're not doing anything that has scope yet. Okay. So declare all your variables up at the top. It's easier for people to find them, and that's pretty standard. Okay? Everybody good with that? And then don't redeclare your variables. I'm pretty sure that, remember how I said start early, because when you run into a problem and get stuck, you get help? Something people get a lot of help for is when they redeclare variables by accident, and then the compiler gets confused. All right, so we have a float result. We've done the division. What do we do after division? By the way, am I going too fast? Too slow? You all good? Send me feedback. If you don't want to say anything in class, please feel free to send me an email separately, privately. Okay. All right, so we did this step in our algorithm, the dividing the numbers as floating point, right? There's our floating result. And now we're going to output the floating point results. How do we output things? Cout. And what are we going to tell it? Let's just say result, because is it still a quotient if it's floating point? All right, we'll call it quotient again. I forgot this quote. All right. Take a quick look at this. Float result equals dividend by divisor. So this is going to do dividend divided by divisor, put the result in float result. When we're done, we're going to go output. It's going to spit this message quotient out with a space, and then it's going to say float result, and the indel will make it go to the next line. This looks pretty good to me. Yes? Yeah? Uh-huh. Let's take a look and see what happens. Let's take a look and see what happens. So this is naturally what we try to do, right? We're going to divide two integers and we're going to get a float, and that should just work fine. Let's see what happens. So I'm going to clear the screen. We will compile. It compiled cleanly. Therefore, we have no syntax errors. That doesn't mean we don't have any what? Semantic errors or algorithm errors. And we'll go ahead and run it now. All right. We're going to do integer or floating point. D for decimal. 22 and 7. What should the answer be? Like pi. And we get 3. Wait a minute. That's not right, is it? Where did the decimal go? I know you know the answer. Okay. Here's the thing. Remember, computers are what? They're dumb, but they're dumb really fast. And if you go back and look up here, here we divided dividend by divisor, and we got an integer result. Here divided dividend by divisor, and we're expecting a floating point result. But it doesn't work that way. The computer is dumb. And the computer decides what kind of division to do, not based on where the result is going, but what two things it is dividing. What two things it's dividing. If it is dividing two integers, it does integer division. If it's dividing two integers, it does integer division. If it's dividing either any floating point, in either top or bottom or both, it does floating point division. Does that make sense? So the computer's dumb, and the way it decides to do division is by looking at what things are there. So we have a problem. We're trying to divide two ints to get a floating point number, but if we have two ints, the computer does integer division. Yes?
Would it help if we inputted 22.0 and 7.0?
It would. Except, here's our problem. In that case, up here, it would have a problem because it would do floating point division and try and stick the result in there. It ends up being weird. And actually, I don't even know what happens if you do mod with floating point numbers. The compiler might not accept that. Yes? So, what we have to do is we have to change one of these integer numbers into a floating point number. We have to change. Now, somebody asked me earlier, and they said, once you have a variable, can you change the type of the variable? And my answer was, no, you cannot. Once the variable type is set, it is set. However, we can cheat. We can cheat a little bit. And what we can do is for particular variable values, we can change the type of the value, but not the variable. Okay? And as you asked, as you mentioned, this is called casting. So let me put a little comment in here and make the font a bit bigger since we're working in this section. All right, so casting is changing the type of the value. There's two ways to do this. Two ways. I will show you the official way, which is called static cast angle bracket float, close angle bracket dividend. I can't remember if I have to have parentheses there or not. I should probably look and see in my notes really fast. Yep, I have to put parentheses at the end. So, okay. So what I've done is I'm saying static cast, and cast means to change the type of value. Change something to a float, and it's the thing inside these parentheses. Change this dividend to a float. Now what this does is it doesn't change the type of the variable dividend. What it does is it says, oh, I'll go look up and see what is stored in dividend, what value is stored in there, and then I will take that value and change it to a float because I've been asked to do this static cast. Yes?
So you're allowed to store values of different types than the type of the variable. Is the type just like a label for it?
No, the type is actually how it's stored in the RAM. It's important. And I want to make clear here that what's happening is the value that's stored in dividend is not being changed at all. The type of dividend, which is an int, because up at the top we said it was an int, is not being changed at all. Both of those things are remaining the same. What is happening is the computer, in its incredibly quick dumbness, says, I will go look in this box named dividend, and I will pull that value out. And I will temporarily hold on to a copy of it. Now, it's an int that I'm holding on to, but I'm going to magically change that int to a float, just for the purposes of this division. Yes, you can think of it as making a copy. Yep.
Could you also, I'm just curious, like go back to the top and declare new variables like a float and
You could do something like that. What I'm teaching you is really the best way to do it. And it's the best way to do it because we could change our algorithm. One way we could change our algorithm would be to ask people whether they wanted to do an integer or floating point choice, and then do the input down here with variables that have the correct types. Does that kind of make sense? But it's easier, in this algorithm what we've done is we've just taken these numbers in as integers, and we're going to convert them. There are many ways to solve a particular problem. The reason I chose to do it this way was so I could demonstrate to you what happens when you're dividing integers and stuff goes wrong. Does that make sense? There's no requirement that we do the output outside the decision. We could decide first and then do the output and have whatever type we wanted. Yeah?
Why don't we need to put the new, divisor in the new box? Why don't we need a new box for it?
Why don't we need, because what we're doing is, I'm going to draw a picture. How's that? Okay? So here's what happens. Here's our memory. Remember, memory is filled with slots. And how many of these things do we have? Billions, right? Billions. And like in 10 years, we'll have trillions, right? We have so many of these things. And what happens is we have, for each one, a name for these, right? So we have, say, int divisor and int dividend. So this is the type, and this is the name. And after we've done some input, what did we have? We had 7 and 22. Anytime you refer to dividend by name, right? If you say, give me dividend to the computer, which is essentially what we're doing when we do these, when we do the divisions, we say, hey, computer, I would like to divide dividend by divisor. And the computer goes and he goes, I'm dumb, but I'm fast, and I know about dividend, it's right there. I know about divisor, it's right there, so I'll divide 22 by 7. And it looks and it goes, oh, 2 ints, when you divide 2 ints, that's always an int, so I will do int division, even though that's not what we want. So here's what we have to do. We have to somehow make this into a float. Okay? Now we're going to do this without changing the type. What happens is this, we get a copy, right? So static cast essentially creates a copy. And when we say it's a float, it goes, oh, it's a float. I'll change that into a decimal. Okay? And it just does this temporarily. It does not affect what's stored in memory. It doesn't. Remember, the computer can pull things from memory and it can do computations with them. And it's fine doing computations, it just won't put them back unless we tell them to. So here, it says, oh, I'm supposed to do something with dividend. I have to turn it into a float, so it makes a copy of that. Then it divides it by divisor, and it doesn't put the float thing back, it puts the result of the whole operation back when it's done. Okay? When it's done, it totally forgets this casted float. We could. We could create a variable like float float dividend equals static cast float, we'd be perfectly happy doing that. Okay. Perfectly happy. But we're just doing it all in one step. It's much more common when you're doing this in languages to do things in one step. Okay. So this is kind of like notation. Everybody with me? All right. Other questions? Yeah. Okay. So here's the deal. If we're dividing things, if we have two integers, it's integer division. If we have at least one float, it's floating point division. So we just did one because that gives us our at least one float. If we wanted to, we could do the bottom two. It wouldn't hurt anything, but it wouldn't help us in this situation. So, all right. So now let's try it and see. All right. We'll compile. We compiled cleanly. That's good for us. Our syntax is right. All right. Do we want an integer or floating point? Do integer or decimal? 22 and 7. Yay, our program worked this time. Are you happy? Yeah?
What about the number of decimals?
We'll talk about that later. Right now, it gives you some number. You can control what number it gives you. We'll talk about that later. Okay. In fact, that'll be important in Project 2 for this class. I'm already working on Project 2, and you're going to have some formatting and manipulation of decimals. Okay, everybody good so far? Great. So we give our program to other people, and they go, okay, integer division, and they go, I want to do integer. And it says, oh, input dividend and divisor separated by a space. Actually, what's going to be funny is this is probably going to work. Oh, wait a minute, it didn't work. I told it to, it said, look, it said I, give me an I if you want integer, I did, and it gave me a floating point result. What went wrong? Yeah. Well, that's what the line said. Oh. All right. So the problem is that I am imperfect, right? I was an imperfect programmer in this time. So here, do you want to change this to lowercase instead? I and D. Good. Now that's going to fix our problem forever, right? I want to do integer division. 22, 7. Wait a minute, that didn't work either. Oh, it's because I'm a dumb person, right? And I hold down the shift key while I typed an I. All right, computer programming is awesome. Dealing with people is also awesome in some contexts, but not when you're dealing with it. Not when you're dealing with it in terms of having to write a program that takes input from people. Okay, it can be really annoying because people are never going to give you what you expect. Okay, or you'll do this, and people are like, "Oh, integer sounds good." And then that gives you an error, right? I don't even want to explain why that happened. But dealing with people is kind of annoying in terms of writing programs because they will do things that you do not expect. Sometimes they'll do it naively. They'll be, well-meaning. They'll just make a mistake. And sometimes they are evil hacker people who will do things to your program on purpose. And they will make your program do stuff it's not supposed to do that you never imagined. And if you keep going on in computer science, I teach a class where I teach you how to write code securely. It's amazing. It turns out that if you are doing input from a person and you don't do it correctly, the person can make your program do whatever they want. They can essentially use your input field to stuff their own program in there, and then your program will switch to running their program. Anybody ever heard of hackers? Stuff like that? That's essentially what they do. They exploit these flaws in software to take over your program and make it do crazy stuff. All right, so that being said, not to make you afraid, don't worry about that in this class. We had this problem, and the problem was that our choice up here was relatively simple, right? All we said is if it's equal to the lowercase I, that's going to be integer. Anything else is going to be decimal, which is why that uppercase I. So it would be nice if we were able to check more than one thing at a time, wouldn't it? Like maybe we could check if it was also an uppercase I. Pardon? Or what? We could check for whatever we wanted. Checking for the word integer gets very complicated, so we're not going to do that. But let's just say, what if we wanted to have multiple choice? Does that sound like a good plan? y'all have multiple choices, or do we just want to call it a semester and we'll quit right now? You won't be able to do very much. All right, let's do multiple choice. This would be a good time to take like a 1-minute stretch break while I just look at my notes really fast. Can't believe y'all didn't want to stand up. It's nice to stand up here once in a while. All right. Okay, so here we are. We have this condition. What we have is an if statement with the parentheses, and we have what's called a Boolean expression inside. What is a Boolean variable or variable expression? Yes? Exactly, something that is always true or false. And it turns out that this equal sign is a Boolean operator, okay? It is like down here, this division sign is an integer operator. It operates on integers. It gives you an integer result. It might give you a float result. Up here we have what's called a Boolean operator. So let me put some notes in the code here, right? So equal is a Boolean operator. Well, it turns out that there are other very useful Boolean operators. Okay? So some other ones are ampersand is known as and, is a Boolean operator. And bar, which on your keyboard is normally near the upper left-hand corner, just like above the enter key or backslash, is called the or, and it is a Boolean operator. So, equal will tell you whether things are equal in value or not, yes or no. And or allows you to put many Boolean values together. Okay? And here's how it works. If you have an equal sign in this is a Boolean expression, and we can use either or and to put multiple ones together. So here's what I'm going to do is I'm going to change the parentheses. I'm going to say if I is equal to choice, or capital I is equal to choice, we're allowed to do multiple choice now. Let me explain formally what these mean. With the or operator, if one is true or the other is true, then the whole thing is true. With or, if one is true or the other is true, then the whole thing is true. And with and, what do you think and is? Uh-huh. If both are true, then the whole thing is true. Or you can say it this way, one or the other is false, the whole thing is false. So, we use parentheses to indicate one Boolean expression, right? So we say I is equal to true. That's going to be either true or false, because equal sign is a Boolean operator. We say I equal choice with a capital I. That's going to be true or false, because that's also a Boolean operator. And then we put the or between them. And if we have the or between them, if one or the other is true, the whole thing is true. Everybody kind of with me on that? You've heard the word and before? And or. By the way, if you really want to be an annoying computer geek, which I on occasion enjoy, you can be very literal in your interpretation of or. So my wife will ask me, hey, do we have any milk in the garage or in the main refrigerator? And I'll go, yes. Because one or the other is true, the whole thing must be true. All right. Just wait. If you stay in computer science long enough, you will make that joke one day. And you're going to go, oh, man, Clay told me I was going to make that joke. I am lame. That's what you're going to think. So, okay. But anyway. Okay. So now if either I is true or the other I is true, we should do integer division. Should we test this and see if it works? All right, let's test it. I'll save it. We will compile it first. That's awesome. Compiled without problem divide. Okay, I, 22 and 7. Ah, that worked. Somehow my output got messed up. Oh, I missed the spaces here. Okay, so that worked. Now let's try, I have to recompile because I changed the formatting. Let's run that again. So capital I, 22 and 7. Sweet. We're happy now, right? Let's try some, yeah, we are. All right, let's try something else. What did something? What, yes? Exactly. So here's what happened, right? Up here in our if statement, we said if one of them is I or the other one is I, then we're going to do integer division. But anything else, even stupid wrong answers, stupid bad input, are going to be floating point. All right? You all with me? You saw that I put an X there? So a better thing to do is to do this. What we say is, well, if it's going to be a lowercase or uppercase I, we'll do integer. Otherwise, what we'll do is we'll check and we'll say, otherwise, if the lowercase d is equal to choice. Sorry, I missed one parentheses. Or uppercase D is equal to choice. Now we're going to do something different. Now we're going to do this floating point thing. Okay. So what I did is I changed our algorithm a little. And the reason I changed our algorithm was to account for the fact that when humans give input, that humans can be obnoxious and annoying. Yeah. Okay. We could do some stuff, but I'm going to show you I'm doing it this way on purpose. Okay? And here's why. One reason why is that if the first one is true, then there's no point to check again in a separate statement below. Right? So if we have this else, we don't have to check. But there's another reason that'll show up in just a second. Okay. Yep. Yeah, I mean we can here. Let me demonstrate that this works first, and then we'll mess around with our if statement. Okay? All right, so clear the screen. Let's see if we can compile cleanly. We do. Divide. Which do we want? Lowercase. Sweet. That worked. Let's try to run again. We'll try uppercase. That worked. Now I've changed the program, and I used to work, but maybe I might have messed up what I had done something, right? So it's always good to test, even though things that used to be working. Oops, well, if I had the right. So that still seems to be working too. What happens if I get a bad number, though? What happens if I type Z? What's going to happen? Nothing happened. Now, if I'm a human user and I ran this, I'm like, why didn't anything happen? People automatically assume it's the computer's fault, right? They go, that dumb computer. And the next thing they'll say is, it probably has a virus, right? Do y'all have parents who help with your computer? It's like, it might have a virus. I'm like, no, it has a human operator. Okay, so the problem is that we input something wrong, and we didn't really get an answer back from the computer that what we were doing is wrong. Does that make sense? So, yeah.
Can we add another if statement?
We can, but we don't even need to. And the reason why is because as I was building this, I was carefully structuring it so that we didn't need to. So let's look at the, I'm going to draw this out really fast in just a second. So first choice is if I is equal to choice, we do that. Otherwise, if I is equal to D, we do this. And we just put an else here, and we say else. And we can output a message, and we say something like, you are stupid, please follow instructions. Right? And if we want, we can be more detailed than that, but we're running low on time, so I'm not going to do that right now. Okay? And so let's see what happens now when we compile it and run it. All right, so we do integer, 22 and 7, that works, that's great. We do decimal, 22 and 7, that works, and that's great. We do z, and we do 22 and 7, and it says, you are stupid, please follow instructions. Okay? Now we were able to catch things. Yeah? Yes, there is a way. And it's magic for right now. I'm not going to tell it to you. Later we'll get into how to go back. Okay? Okay, so I'm going to sketch out using a flowchart essentially what we've done. Okay? Because a flowchart is really nice for this. So here's what we did. Here we decided, is it I, lowercase I, or uppercase I? And if the answer is yes, right, we do the calculations. But if the answer is no, we say, oh, if it's not I, is it uppercase D or lowercase d? And if the answer is yes, we do some calculations. And if the answer is no, at this point, we know some stuff, right? And we know when we reach here, we already know that it is not I, and we already know that it is not D, right? And so at this point, we know the user is stupid and that they're unable to follow instructions, and we're able to do, I can't really draw parallelograms very well. Can I? That's really bad. We do some output and we tell them. If we had split these into separate if statements, the logic gets kind of more confusing, but we could do it that way. Okay? Yeah? Sure. Absolutely. Yeah. Sure. Do you want to? We could do that. You'll probably do that in your other program. But as we say, you can see now that when we have this problem, there's many different algorithms that will solve it that kind of have different properties for output and stuff like that. All right. I think that's enough for today. Thank you for being in attentive class. I actually had a really good time teaching today. I hope you enjoyed it too. See y'all later.